Hi teachers, welcome back to TLS Physics Specialization Test Training Program. So in this video, I'll explain about one-dimensional translational motion. Um, I will be discussing 20 multiple choice questions, mainly about kinematic quantities. I hope definitely this will help you to prepare for your physics specialization test. So if you watch this channel first time, kindly like and subscribe this channel so that you will get the new notifications. Let me go to the question number 1. Example for non-inertial frame of reference. So basically, what is a frame of reference? A frame of reference is a system of coordinate axes attached to a clock or connected with a time. So coordinate axis with time. So that is called a frame of reference. And frame of reference basically you can divide into two: inertial frame of reference and non-inertial frame of reference. So in inertial frame of reference, the frame of reference, it can be at rest or moving with a constant speed. That means Newton's first law is valid. And another one, non-inertial frame of a frame of reference is or accelerating frame of reference, or in which Newton's second law is valid. So here they are asking example for non-inertial frame of reference. So in non-inertial frame of reference, that means it should be a rotating frame of reference or accelerating frame of reference. So let us see the options. In the first option, a body at rest. Here first law is valid. A car moving with uniform velocity. Again the first law is valid. And a body moving with variable velocity. So variable velocity, there is a possibility of change in velocity, that means acceleration. And a body moving with a constant speed, again it is dealing with the first law. So option A, option B, option D, all these things are related with Newton's first law. Okay, so the only option related with the Newton's second law is option C. So a body moving with variable velocity is the correct answer. That is related with the, that is an example for non-inertial frame of reference. Okay, so let us go to question number 2. Which law of Newton's is valid in inertial frame of reference? So I already told you in question number 1, frame of reference are of two types, inertial and non-inertial. In inertial frame of reference, Newton's first law is valid, and non-inertial frame of reference, Newton's second law is valid. So here four option: first law, second law, third law, none of this. So the right option is option A. Inertial frame of reference are those frame of reference in which Newton's first law is valid. So the right option is option A. We'll go to question number 3. Name the path followed by an object during its motion. Four options are given: distance, displacement, velocity, trajectory. You know what is the difference between distance and displacement? So distance is the total length of the path covered by the body during its motion, and displacement is the shortest distance between initial and final point during its motion. So option A and option B both are wrong because it is not the path followed by an object. And option C, velocity is nothing but the rate of change of displacement. So that again it is not dealing with the path followed by the object. The right option is option D, trajectory. So what is trajectory? Trajectory is the name of the path followed by an object during its motion. It can be a straight line, it can be a curved line, it can be a parabolic, anything. Alright, so we will go to question number, so here the right option is option D, and we will go to question number 4. Example for one-dimensional motion. So basically you can classify motion into three types: one-dimensional, two-dimensional, and three-dimensional. So in one-dimensional motion, only one coordinates out of 3, only one coordinates will change with respect to time. In 2-dimensional motion, 2 coordinates will change with respect to time, and in 3-dimension, all the 3 coordinates will change. So example for 1-dimensional motion is option A, linear motion. You know that linear motion only one coordinate will change. It can be along x-axis, it can be along y-axis, or it can be along z-axis. And rotational motion, rotational motion, anytime 2 coordinates will change. Maybe x and y or x and z, any 2 coordinates will change. In circular motion, again the 2 coordinates will change. And oscillatory motion, there can be changes in 2 variables. So the right option is linear motion. In linear motion, only one coordinate will change with respect to time. So we say the example for 1-dimensional motion is linear motion. We'll go to question number 5. Identify the scalar quantities among the following. So you know that the physical quantities, based on its magnitude and direction, we can classify into 2 types. Physical quantities divided into 2. One is scalar quantities, another one we will call vector quantities. So in scalar quantities, they have only magnitude and no direction. And in vector quantities, there are magnitude or measurement along with the direction. So let us check the options. Option A, work. Option B, force. Option C, velocity. Option D, momentum. First, let me go to force. Right, the force, that we have, whenever we say about force, you will come to know the direction, which direction force is acting. Okay, force, we have magnitude and direction. And velocity, of course, speed with the direction we will call velocity, so it is also a directional quantity. And momentum is nothing but mass into velocity, again it's a directional quantity. So option B, option C, option D, all 3 answers are wrong. The only one option is work. Work is a scalar product of 2 vector quantities, but it is considered as a scalar quantity. It has only magnitude, no direction. So the scalar quantity among the following, the right option is option A, work. Let us go to question number 6. Identify the vector quantities among the following. As I said earlier, physical quantities you can divide into 2, scalar and vector. But vector quantities have both magnitude and direction. Let us check the options. Temperature. So whenever you say what is the room temperature, we say 24 degrees Celsius or 27 degrees Celsius. Alright. So we never say about the direction. So it is a directionless quantity. And acceleration. Option B, acceleration. You know that whenever we speak about acceleration, it is nothing but a rate of change of velocity. Velocity is a directional quantity, so change in velocity is again another directional quantity. Option C, mass. Mass is nothing but the amount of matter contained in the body. So there is no direction, only the measurement. And option D, time. Time is also not a directional quantity. It has only magnitude. We say time is 10 past 12 or 10:15, like that. We say the only magnitude or the measurement. We don't include the direction. So in these 4 options, option A, option B, option C, option D, the correct option is option B. Acceleration is the vector quantity. Let me go to question number 7. Identify the graph of a stationary body. Identify the graph of a stationary body. So here distance time graph is shown. In all 4 options we have distance time graph. So in the first graph, option A, here you can see as time increases, distance there is no change. And option B, you can see as time increases, there can be increase in distance. So if time increases, if there is a with respect to time, if there is a change in distance, you can say the body is in the state of motion. And here again, as time increases, the distance increases. So here you can say the body is in the state of motion. And here as time increases, the distance increases, the body is in the state of motion. So only in option A, there is no change in distance with respect to time. So we say the body is in the state of rest. So the graph of a stationary body is nothing but option A. We'll go to question number 8. The revolution of a planet around the star is an example for. So I already told you in the previous question, motion you can divide into 3 categories: one-dimensional motion, two-dimensional motion, three-dimensional motion. Right? So circular motion or orbital motion, the planets are revolving around the sun or the star, is an example for circular motion or orbital motion. So here in orbital motion or circular motion, what happens? Two coordinates changes with respect to time. So if any two coordinates are changing with respect to time, we say the motion is coming under two-dimensional motion. If only one coordinate changes with respect to time, we say it is only one-dimensional motion. If two coordinates are changing with respect to time, we say it is two-dimensional. If all the three coordinates are changing with respect to time, we say it is three-dimensional motion. So here, the revolution of planets around star is an example for two-dimensional motion. So the right option is option B. Let me go to question number 9. The slope of distance time graph gives. Basically, what is distance time graph? In a distance time graph, distance is mentioned along y-axis and time is mentioned along x-axis. So that will give you an idea about distance of the body during its motion. So basically, what is the formula for slope? Slope is nothing but change in y quantity divided by change in x quantity. So here the in y coordinate y axis distance is mentioned and x axis time is mentioned, right? So distance by time will give you speed, area, volume, acceleration. So all of you know it's a simple question. All of you know the basic formula: distance by time is nothing but speed. So the right option is option A, speed, not area, not volume, not acceleration. So the right option, the slope of distance time graph, is nothing but speed. Let me go to question number 10. The slope of velocity time graph gives. Here the slope of velocity time graph gives, again slope, that change in y quantity divided by change in x quantity. So what is velocity time graph? Velocity is mentioned along y-axis and time is mentioned along x-axis. So the slope of velocity time graph is nothing but velocity by time, that will give you acceleration, right? So slope of velocity time graph gives acceleration. So the option A, it is speed. No, it is not correct. And option B, displacement, again it is not correct. Option C, volume, it's not correct. And option D, acceleration. So the right option is acceleration. Once again, the slope of velocity time graph gives the acceleration and the slope of distance time graph gives speed. So that's the difference. You have to keep it in your mind. All right. So we will go to question number 11. The area under velocity time graph represent. Okay. So I told you what is velocity time graph. Velocity is mentioned along y-axis and time is mentioned along x-axis. So the area under velocity time graph represent what? So area, that basically it is length into width. All right. So when you multiply velocity into time, you will get what? What is this velocity? Displacement by time. So displacement by time will give you velocity. So if you multiply velocity with the time, you will get displacement. So here are the options: speed, displacement, volume and acceleration. So the right option is displacement. Area under velocity time graph gives displacement. So if you see the velocity time graph, you are able to calculate the displacement of the body during its motion. All right, we'll go to question number 12. Identify the nature of velocity time graph of a body moving with a constant velocity. So here again, velocity time graph, as you know, when this one in this graph, velocity is mentioned along y-axis and time is mentioned along x-axis, right? So now the nature of the motion is body moving with constant velocity. Velocity always remains constant. For example, if it is 20 meter per second, it will throughout the time it will be 20 meter per second. So it will be a straight line. So the one option it will be a straight line. So okay, and option B is straight line parallel to time axis. Straight line parallel to velocity axis, none of this. So I think it can be it will be a straight line, but the best fit option will be option B, straight line parallel to time axis. That's the correct answer. It can be a straight line. It parallel to velocity axis, no, and it will be a straight line if it is coming with if the straight line is aligned at an angle of 45 degree, right? So it is not the perfect answer. So the perfect answer is straight line parallel to time axis. Okay, so that is the correct answer. So that is the nature of velocity time graph of a body moving with constant velocity. All right, we'll go to question number 13. The area under velocity time graph gives. The area under velocity time graph. So you know that the area under velocity time graph gives what? So you know the velocity is mentioned along y-axis and time is mentioned along x-axis. So the area under velocity time graph gives, of course, it will be displacement, right? It is velocity by displacement by time is velocity. So velocity time graph gives the displacement. All right. Now, question number 14. Identify the nature of motion from the given velocity time graph. So here we have a velocity time graph. From the graph you can understand. As time increases, there is no change in velocity. Velocity remains as a constant. For example, time is equal to 0. It has a particular velocity. For example, 10 meter per second. As time is 1 second, 2 second, 3 second, you see the velocity remains constant. So the option A, body is moving with the uniform acceleration. Body is moving with uniform acceleration. No, it is not getting accelerated. Body velocity remains constant. So we cannot say option A is not correct. And as you go to option B, body is moving with uniform velocity. Yes, body is moving with uniform velocity because always velocity remains as a constant. Body is moving with zero velocity. No, velocity is not zero. It has a particular value. It is not zero. Zero velocity means what? Body is not moving. And body is moving with zero speed. No, it has a particular value. Alright. So the right option is body is moving with uniform velocity. Alright. We'll go to question number 15. Two objects A and B are moving with the same velocity of 10 meter per second. The relative velocity of A with respect to B is, you know what is the formula for relative velocity? Velocity of one object with respect to another. It is nothing but V1 minus V2 or VA minus VB. Right? So velocity of the relative velocity of A with respect to B is VA minus VB. So here both are moving with the same velocity. So both are in the same direction. Okay. So it is 10 minus 10. It will be 0. Okay. So the right option is option A 10 meter per second. Option B 20 meter per second. Option C 30 meter per second. Option D 0 meter per second. So the right option is 0 meter per second. Okay. Alright. We'll go to question number 16. A car travels in a circular path of radius 100 meters, taking 20 seconds on each lap. The average velocity on each lap is. So here we have a circular path. We have circular path. and radius is 100 meters, taking 20 seconds on each lap. To complete one complete circular path, it will take 20 seconds. So average velocity on each lap, there are 4 options given: 5 meter per second, 0 meter per second, 10 meter per second, 2000 meter per second. So basically, you know the this average velocity formula. Average velocity is nothing but total displacement by total time, right? So when it completes one lap in a circular path, you know the total displacement will be 0 and the time taken is 10 seconds. So the right option will be correct answer will be 0 by 10, it will be 0 meter per second. So the average velocity is considered as 0 meter per second. All right. So now in question number 17, a particle is moving with constant speed in a constant speed in circular path. Which one of the following statement is true? So there are 4 options. Option A, the speed of the particle is constant, the velocity of the particle is constant, the acceleration of the particle is constant, all the above. Particle is moving with a constant speed in a circular path. It got uniform motion and moving in a circular speed. You know, when it is moving in a circular path, the speed of the particle is a constant. Uniform motion means with a constant speed means the particles the speed remains constant. Of course, the option A is correct. The velocity of the particle is constant. That is very, very important. When the body moves through circular path, you know, the direction of the motion always changing. All right, so you cannot consider this as a here velocity is constant and the acceleration of the particle is constant. Okay, so direction of acceleration is always, it is acting towards you know, whenever a body moving through a circular path, always there is a change in velocity. Of course there will be change in the acceleration direction also changing. So you cannot say that acceleration always remains as a constant. Of course all the option is all the above option not correct. So when the particle is moving with a constant speed in a circular path, the speed of the particle is constant. Speed of the particle is constant. All right. So now we have a graphical question. What is the nature of velocity when time is 4 seconds to time is 9 seconds in the given diagram? So in the given diagram, you can see that it's a velocity time graph. And here you know, time is equal to 4 seconds. When time is equal to 4 seconds, what is the velocity? It is 6 meter per second. When time is equal to 9 seconds, its velocity again 6 meter per second. So here from time when time is equal to 4 to time is equal to 9, time is equal to 4 to 9, the speed remains, velocity remains as a constant. Its speed is not changing with respect to time. So its speed is what? Its velocity remains as a constant. So velocity is 0? No, it is not correct option. Velocity is constant. Of course, from 4 to 9, the velocity remains as a constant. It is 6 meter per second. Throughout motion, no. Only from time is equal to 4 to time equal to 9 seconds. And velocity increases? No, there is no increase in velocity or no decrease in velocity. So the correct option is option B, velocity is constant. Now we go to question number 19. What is the nature of velocity when time is 9 seconds to 12 seconds in the given diagram? So here we just now discussed in question number 18 what happens for the body during its motion from time equal to 4 to 9 seconds. Now again we are discussing 9 to 12 seconds. So 9 to 12 seconds, you can see that the velocity graph uh, here the velocity decreases, right? So as you go from time is equal to 9 to time is equal to 12, the velocity decreases. Okay, there is no increase in velocity, it is not remains as a constant. So option A, velocity is 0, velocity is constant, velocity increases, velocity decreases. So the right option is velocity decreases. Right option is velocity decreases. Alright. So this this one, the correct option is velocity decreases. The next question is, what is the nature of velocity when time is equal to 0 seconds to time is equal to 4 seconds in the given diagram? So in this three options here, it is uh, from time is equal to 0 to time is equal to 4 seconds. What is given? Velocity is 0, velocity is constant, velocity increases, velocity decreases. So you can understand that when time is equal to moving from 0 to 4 seconds, its velocity increases. So the right option is velocity increases, option C. Alright, so I hope this video will be beneficial for you. It will help you to score better mark in TLS physics examination, and also to have an idea about kinematic quantities. If you like this video, please subscribe this channel. Thank you.